In the FISH lab, we looked at the preparation of the data set for the time series model. In this lab, we will explore a data set. So here we will read the data collected by Auckland Transport. It represents the total number of passengers across the public transport network, aggregated to monthly timestamps from July 2005 to July 2022. We import OpenPy Excel and we import pandas as PD to read the Excel file. Read Excel data, we will need to change our file path accordingly with where the data file is. Let passenger underscore data equal PD, that's pandas library, dot read underscore Excel of Auckland Transport Monthly dot XLSX. Printing the passenger data, we get this. So we get the month and year and the passengers in thousands. We can see the date format from Excel that often gives you grief has behaved here and can be converted to a date time format. We see that it's automatically reverted to year, month, day format. Fixing the date time formats in Excel can often be easier compared to Python. Plotting the data. So we have to plot the data, we will import the library matplotlib.pyplot as PLT. Let fig, x equal plt.subplots of fig size equal width 15 and height 5. X dot plot of passenger underscore data of month year, that is on the x-axis, and passenger data of passengers thousands column, that's the y-axis, and color equal k. Then x dot set underscore title of passenger trips across the Auckland transport network will give us the title. X dot set y underscore y label of passenger thousands will reset the label of the y-axis to passengers in and bracket thousands. plt.show open and close bracket that prints the plot. So from the plot we can see that from the year 2006 to 2020 it shows a linear increase. And every year there is a cycle, looks like a monthly cycle. So 2007 is somewhere in the middle of 2006 and 2028. So we can see that every year there is some form of cycle, and that repeats every year until 2020, when there is a decline in the passengers. And that is when the COVID lockdown started. and the biggest decline was sometime in February 2020. And then it increased. Probably the lockdown opened for a while, and then it decreased and then increased. So around 2021, we see again a decline. So a major decline also occurred near 2022. So there was a very huge decline in passengers near 2020 and near 2022. So this is because of the COVID lockdown. Discussion points. So trend. So if we want to look at the trend, then the trend is a linear from 2006 to 2020, and then after 2020 we can't see a good pattern. And the cycles, we can see the cycles are repeating every year. Every year there is a cycle, and the similar kind of cycle repeats every year. And 2020 onwards, something this is because of the COVID lockdown that there is a major decline in the passengers. We can take a look at the seasonal behavior. Plotting each year has a separate line or has a box and whisker charts. Both can be useful for examining month-wise. Month-wise is the seasonal and year-wise is the trend distribution. So if we look at the month-wise for pay year, we can see there is a cycle, and that cycle repeats month-wise for every year. We prepare the data. We prepare the data for exploring the data. So this is how we do that. We will create some more new columns to prepare the data. Create a new field for year. So passenger data, a new column year equal, we will put it in array form. So we will put a square bracket around. We'll say D dot year for D in passenger data of month year. So for each row, there is a month year, and from that month year we will look at the year portion, and printing the passenger data dot head gives you can see the new year column contains 2005, 2005, 2005, 2006. Create a new field for month. So now we are creating a new field for month. Passenger data of the new column month equal square bracket D dot href time of percentage small b. Now percentage small b, that will give us the first three letters of the month for D in passenger data month year. So for the first row, the month year shows is July, so month should be JUL, as you can see. For the second data row, it's August, so AUG, and then September, and then October, November, December, January, February, March, April. Create an array of years. Let years equal passenger data year dot unique open and close bracket. Printing the years column. gives us 2005, 2006, 2008, 2009, 2010 up to 2022. This is the same as let list of years equal array, empty array. Let list of months equal empty array. For I comma rows in passenger data it dot ita rows open and close bracket colon date data. Let date data equal rows of month dash year. Year equal date data dot year. So from the month year, we are extracting the year. From the and list of years dot append bracket year, that will add this year to the array list of years. Let month equal date data dot strf time of percentage B, and percentage B is first three letters of the month. List of months dot append month. So the month in first three letters gets added to list of months. Let passenger data of the new column year equal list of years. Passenger data the new column month equal list of months. Display first few lines. Passenger data dot head of first 10 lines is this, and similar, it's same as what we have done before. So what are our years of interest? Let years equal passenger data of year column dot unique open and close bracket, and printing the years that prints from 2005 to 2022. Now we import calendar because we want months. We want the list of months from the calendar. So we are importing the calendar library. Make a list of months in the calendar. Let months equal empty array. For item in list of calendar dot month underscore name in square bracket 1 colon, that will read the row 1 and onwards. Months dot append item and bracket colon 3. So colon 3 will put first three letters in the months array. Print months, we get this. Now we plot the data as lines. We will look at this in the next lab, plotting the data as lines.